Now we're going to look at the ruler postulate, and basically this is a way to measure the length of a segment. So we have a segment here, ST, and we want to measure it to the nearest tenth of a centimeter. So if we do this, there's a couple ways we can do this. Normally what we'd do is we'd put the ruler so that 0 was at S and then just measure the distance. But you really don't need to do that. In this case, what they did was they put the S at 2 centimeters and they put the T at 5.4 centimeters. And then what we can do is just subtract those two numbers, take the absolute value of it, and we get our answer. So in this case, using the ruler postulate, we take 5.4 minus 2 because T is at 5.4, S is at 2. Subtracting those two and taking the absolute value, we would get a length of 3.4 centimeters. Using the same idea with some guided practice, we're going to measure the length of a segment to the nearest eighth of an inch. So if we look at this segment right here and I pull out my ruler, and what I'll do is I will line it up actually so that this is at 0 for the inches, and then I'm going to move this over until it hits where the N is. That's approximately where it is to the nearest eighth of an inch. 1.875 ends up being 1 7/8. So my length here from here to here is 1 7/8. Again, if I wanted to, I could have moved this to 1 centimeter here and then move this back. And if you notice, again, this does it for us, but we could say 2 7/8 minus 1 gives me 1 7/8. So in either case, we'd get the same distance. All right, and so again, the distance here is 1 7/8. We're going to do it one more time. We're going to take out our ruler. This one's a little bit easier. I'm just going to line this up at 0 here. And again, we're using inches this time. Or yeah, so we line it up and it's exactly 2 inches in this case. So that's pretty easy actually. If we were to write this out in words, we would say 2 minus 0 to get our answer and do the absolute value. All right, now we're going to look at the segment addition postulate. This tells us that if we have a point that is in between two other points, and in order for it to be between, we have to be able to draw one line that goes through all 3 points. We want to find the distance from Lubbock, Texas to St. Louis, Missouri. If you notice, from Lubbock, Texas to Tulsa, it's 380 miles. From Tulsa to St. Louis, it's 360 miles. So all we have to do here using the segment addition postulate is add up the distance from L to T plus the distance from from T to S. So that will give us the whole distance, which is LS. Again, LS will be the first part, which is Lubbock to Tulsa plus Tulsa to St. Louis. So LT is 380. TS is 360. Together it gives us 740 miles. Now we're going to use this picture for examples 3 and 4. For the first part of this, we're going to find the length XZ, so from here all the way over to here. If you notice, Y is in between X and Z, so all we need to do here is add XY plus YZ, which will be 23 plus 50, and that will give us our whole length, which is 73. And let me write that out real quick, just that we know what's going on. We want to find XZ, so really that is XY plus YZ, and that is going to be 23 plus 50, which gives us our 73. For the second part of this, we're going to look at the diagram again, the same diagram, and if you notice it says that WY right here from here up to here, this is 30, and we want to know the distance from W to Z. Now the problem is we don't know what the distance from W to Z is, and that's because W is not in between X and Z. Y is in between X and Z because we can draw a line that connects all 3 of them, but we cannot draw a line that connects, for example, XW and z. So therefore, w is not in between x and z, so we do not know what the distance from w to z is. All right, and that's all we have for these examples.